Okay, so you've got your data coming out of your devices into IoT core, potentially put into a Kinesis stream. What are you going to do with that data? So data turns into information in different ways as it ages. So I've rather arbitrarily broken up into young, middle-aged, and elderly, and you'll note that all of them start at 0. All information is relevant from the time it arrives. So young data, which I say 0 to 4 hours, but is really probably more like 0 to 30 minutes, is useful for feedback and alerts. As I showed in the last talk, if you have a temperature spike, you want to be able to alert someone. That alerting, the information that you had a temperature spike may not be relevant a couple of hours after it happens. Hopefully someone goes into the room and says, oh, so last person in the room really pushed the thermostat up, let's turn it back down. Or if you have a smart thermostat, the person just uses their cell phone to do it. The middle-aged data is where most of your work is going to be with the data. And the idea is analytics and reporting. Let's say, for example, you're merging the data with heating costs. This is where you'd pull the data in. It probably matters within a few weeks, probably doesn't matter longer than that. It's actionable data. It's letting people know what's going on. It's basically working with stuff that has a short-term but not immediate feedback loop. And finally, the so-called elderly data. If you're doing machine learning, you always want to be able to validate your algorithms against a very large corpus of data. And also auditing, depending on what field you're in. You might need to save your data forever so that at some point auditors will come and look at it and verify that you haven't done anything mistaken with the data. And these three general characteristics have three different storage locations. The first for the young data is you're going to be pulling it right off your stream. Either you're going to be invoking right off of IoT core, or if you use Kinesis, you're going to be attaching lambdas and analytics into the Kinesis stream. The middle-aged data, you can use database or a data lake, and Amazon looks towards the data lake, but there's reasons to use both. And then finally, the elderly data, partition data lake. You want to group your data, your older data, for example, by date. Maybe you do multiple partitionings. We'll talk about that in a minute. Databases for IoT kind of have a bad reputation. After all, why would you be putting data into, say, Postgres? Well, the fact is Postgres can handle 100 million rows of data without any problem at all. And where databases such as Postgres are really, really useful is that you can join the data. So let's say you have a feed of data that contains your external temperatures. You might find some very valuable information by joining that feed of external temperatures against your raw feed of room temperatures to say, okay, this particular room reacts differently to outside temperature and heating. Time series databases are a somewhat different approach that they focus on the storage of your data, making it very efficient, especially for data that you keep adding. And there are various approaches to time series databases. Timescale, for example, is an extension that's added to Postgres, so you can interact quite a bit with normal Postgres behaviors. InfluxDB is a time series that kind of bridges the gap a little bit between database and search engine. You can use SQL for your queries. You can also, it indexes data based on attributes. Time series also gives you certain enhancements, such as gap filling if you do a query. It can populate values. You could say, give me this time series by minute. Your data may be at arbitrary points in time. It can figure it out. And it can also do aging out of data automatically. So you can set up a retention rule that says, okay, detailed data for a week, after a week, downsample that, after a month, just throw it away. Kind of a different approach is to use a search engine. People don't think about search engines necessarily in the same vein as databases, but they really are. They're simply optimized for search patterns where you know explicit values. So date ranges are explicit values, right? There are only 365 days in a year, 24 hours in a day. you can construct a query for a search engine with a very limited number of values, and the search engine can run and retrieve that data very quickly. Search engines such as Elasticsearch are also sharded across multiple machines. There's if you go to the Elastic blog, they'll give you lots of examples of using Elasticsearch to store and manage time series data. Finally, I throw DynamoDB up here as something you probably don't want to use for storing your data. And I say probably because there are cases where you might want to do it. If you want to track data by date and device, where you have a very specific primary key and you're retrieving a whole bunch of data that's stored in one row in Dynamo, one item in Dynamo, that might work. If you're storing your data in Dynamo and then running queries, you should be prepared to spend a lot of money to bump your read capacity up to be able to do that. If you're storing a lot of data, the data lake is really one of the approaches, and storing data for long term. And a data lake is the idea that you have a vast reservoir of storage. I'm going with the hydroelectric dam a little bit too heavily here. You have a vast reservoir of storage, basically stored just as flat files. You can use JSON, but there are more appropriate file formats. And then you have a lot of CPUs that can read that and just scan through it. You don't index your data at all. You read the entire data corpus for every query, which is why partitioning makes a lot of sense. And there are a lot of tools to do that, but if you're, and Eric will talk about that later, a couple things to think about for your data is it's not an ocean. Partitioning is very important so that you only look at part of your data. Don't just dump everything in. I like to think of the Finger Lakes in New York, which if you're familiar with them, there's 6, or depending on how you count, up to 12 lakes that were scratched out by glaciers. And they each have their own characteristics. All of them are wine-producing regions. But think about that for your data lakes. Different data in different lakes. So the raw data, which you might use for archiving. Cooked data, as I call it, is things like the 5-minute moving average of temperature. That may be very useful, but don't mix it in with your raw data. And auxiliary data, such as your outside air temperatures. And then, if you're doing this, try and be lake-friendly. There are a lot of data formats in the world. Parquet is a format that works very well when you're writing queries against specific columns, because it maintains each column of your data independently, so you can only need to read that portion of the file. JSON, you have to read everything. JSON might be valuable. It might be the right format for audit archives, because that's what you get from the devices. If you do that, always gzip. Storage is cheap, but it's not free, and analysis on large files is expensive. I've mentioned auxiliary data. Try and acquire that at the same time. So I use the outside air temperature. The National Weather Service gives you an endpoint where you can retrieve every hour the current temperature for your location. Going back in time, it's not that easy. So capture the data when you get the raw data, put it in the lake, have it in a format so that you can merge the two at the end. And as I said, relational database is a great way to wire things together. Okay, retain everything. People are afraid of storage costs, and as I'm going to show in my last talk today, storage costs are not where you should be afraid. So again, partition stuff, make it logically distinct, but hold on to it. There's no reason to let go. Think of your active data as just a part of your total data. Of course, saying that, sometimes things get in the way. We have the California Consumer Privacy Act, which is coming into effect in January, I think, which has some very strict restrictions on being able to delete data. For IoT data, this may or may not matter. It's generally going to be anonymized, right? You have a device ID and readings for the device. If you can't track that back, maybe it doesn't matter. On the other hand, you might have corporate records retention. Some corporations want to retain everything. Some don't want lawyers to be able to discover their data and are very specific about, we retain data for 12 months, then it must be purged. And lastly, I want to talk about partitioning. And again, as I keep saying, data lakes, should have data that's logically consistent, but always remember that you're going to be paying for data that you keep in the data lake. You're going to be paying to store it, you're going to be paying to analyze it. The analysis costs are going to be your big costs. So rather than having, huge directories, I say directories knowing that S3 is not really directories, instead of having huge directories with every day that you've ever recorded data, break it down. Use your file system to subdivide the data so that you can then write a query that just looks at the last week, even though you're storing 10 years of data. And Athena, which is Amazon's tool for SQL-based analysis of data lakes, lets you use a convention where you basically define column names that are based on the file system structure. And that can be very useful. Lastly, plan for change. Things are going to change. You may shift suppliers of your sensors and they put the temperature sensor a quarter inch further from the CPU or closer to the CPU, and that suddenly means that all of your temperature readings from these new sensors are different by 1/10 of a degree. Doesn't seem like much, but it could change what's coming out of your modeling software. And you have to think about how you want to deal with it. Do you go back and rewrite your old data? I don't know. I don't have the answers for that. I'm merely pointing out that you should plan for that, and you should retain as much metadata about the incoming data as you can. It's not enough to simply say sensor ID. It's this sensor ID is associated with this particular brand of sensor. And lastly, going to Don's examples of sensors that are /home/kitchen, remember that sensors may be repurposed, okay? What was the kitchen sensor yesterday might be the basement sensor tomorrow. So always plan for that, and to the extent that you can, keep things as generic as possible. A device ID is probably a better choice than saying this device is the kitchen device. Even though for our workshops, for example, and many of our slides, we put in names that just make it look a lot easier. So I can say that Keith Arduino is different from Steve's Arduino, is different from Ken's Arduino.